Welcome to P4. Today we are looking at magnitude and direction, unit 7.3. Now just before we get started, hit that subscribe button please if you haven't already done so. As you can see, it's about 60% of my return viewers are still yet to subscribe. So please do, as it really will help me out and help others find my channel. So, magnitude and direction of a vector. Nice and relatively easy. It's just building on knowledge you already have. So imagine I have this vector A here. It's going to have a horizontal distance and a vertical distance. Okay, the horizontal distance will be some value of I, and the vertical distance will be some value of j. And this vector will obviously be something I plus something j, or as a column vector like that, where obviously I'm using the x and y as the unknown horizontal and vertical values. Now, when I said it's building on previous knowledge, it is building on some very old knowledge. So you think about your horizontal and your vertical components of your vector, and they're always going to make this right angled triangle, which means we can find this distance because magnitude is just the length of this vector. That's all it is. So we can use Pythagoras to find that length. Okay, now when we're talking about magnitude, we put it in what you'll know as modulus signs, just these straight lines. This means the magnitude of vector A, or the length of vector A. And then Pythagoras would be x squared plus y squared. Okay, it's the x distance and the y distance. Remember that the value of I and the value of j just mean units in that. I is just units in the horizontal direction, and j is units of length in the vertical direction. So it's the number in front of them that's important. Now, before I look at some examples on that, let's also look at the direction. So the direction can be found quite easily. For example, if I look at the direction here where I marked theta, I know that tan theta is my opposite over my adjacent. So tan theta is going to be y over x, or theta will be tan to the minus 1 of y over x. Okay, so that's quite nice and easy, and again it's just previous knowledge. Now going with that, and I'll pop this in red here, you could be looking at an angle here, which I'm going to call alpha, and obviously alpha plus theta is going to give me 90 degrees. Now, when we're talking about the direction of a vector, we usually measure it or describe it to the horizontal, the I, or the vector I, okay, or the positive x-axis. But sometimes we do look at it to the vertical, where we might be talking about the positive y-axis or the vector j. So it's usually one or the other. More likely to be this one where I've done theta, but equally it could be this one. Okay, again, you can work it out, straight from alpha as well. Because if I think about this, and I'll put this in red here, you've got your x. So, you can look at tan alpha being opposite over adjacent. So alpha would be x over y. Okay, personally, stick with this one, but I think actually if I take a step back, it's probably easier if you can do a little sketch of your vector within the question and put your angle on it, then you should be able to work it out without remembering any of these. Okay, equally, without really even remembering this, remember it's just Pythagoras. You know, that should be ingrained in you by now. And then finally, we're often asked to find a unit vector. So we looked at unit vectors in terms of I and j previously, one unit this way, one unit this way. But if I have a diagonal line, it doesn't quite work that way. So if I have a diagonal line, then I would have to divide by the modulus to get this as a unit of one length. So if this length was 10, I would divide vector A by 10 to get it as a unit 1. If this vector length was 25, I would divide by 25 and then it would be of unit 1. Okay, hopefully it'll make a little bit more sense when I go through a couple of examples in a moment. First example, given that a vector A, which is 5i equals 12j, find a unit vector in the direction of A. Okay, nice and easy. So the first thing we want to do here is find the modulus of A. So this is going to be 5 squared plus 12 squared, then square rooted. Okay, so when I do this, I should get 13. So it's 13 units in length. And then if I want to find a unit vector in the direction of A, well, A's direction is 5i plus 12j, which is obviously of length 13. To make it of length 1, I need to divide it by 13. So there I get the unit vector is 1/13 5i plus 12j. Okay, second example. Find the angle between the vector 6i plus 2j and I. So 6i plus 2j is just a vector something like that. And pop these in here, 6i, 2j for helps, and it's going to be the vector it makes with I. So I is obviously one unit in that direction. Okay, so it's a horizontal unit that we're making the angle with. So this now should be nice and easy. This is obviously 6i plus 2j, pop that there. Sometimes what I do is I don't even put the i's in or the j's when I'm popping these values on. You know, it's not always necessary really. So what we want to do is simply look at tan theta is opposite over adjacent. So theta equals 18.4 degrees. And this is to 1 decimal place. Now, if you're doing angles, I think I've said it in the past, but 1 or 2 decimal places or 3 significant figures is probably your best protocol there. It often does say in a question, though, what it might want. But yeah, I think 3 significant figures is generally the go-to with angles, but equally 1 decimal place or even 2 sometimes is useful. Now, second example here, we've got vector A and vector B. Find the exact value of modulus of A minus 2B. So we've got A minus 2B, and we want to find that as a single vector first. So that's 3, 2, minus 2 lots of 2 and minus 1. So we get the vector 3, 2 minus 4 minus 2. So that's going to give me the vector of minus 1, and then 2 minus minus 2 is 4. So my vector a minus 2b is minus 1, 4, or minus I plus 4j. Now if I look at the modulus of this, so the modulus of this will be that minus 1 squared plus 4 squared, and then square rooted. So we've got 1 plus 16, so it's the square root of 17. We want the exact value, so we'll leave it as it is. Obviously, if it can be simplified in terms of its surd, then you can do that. Obviously, your calculator will also do that for you. So there should be no excuses not to simplify this surd. Now, final example. Write the following vector in I and j form. So you can see here we've got this vector. I'm just going to put it in my horizontal and vertical. Now I prefer to turn it like that with that 30-degree angle, but equally I could have joined across here and used the 60-degree without any issues. Now this is obviously my x and my y. And if I think about this logically, we know that sine 30 is opposite over hypotenuse, and cos 30 is adjacent over hypotenuse. So using my previous knowledge, and then we've only got one unknown in each equation. So y is going to be 20 sine 30, and x is going to be 20 cos 30. So that means my y value is 10 and my x value is 10 root 3. So that means this vector, whatever we want to call it, whether it's got a letter or not, we can call it, let's call it A. So vector A is 10i plus 10 root 3j. Nice and easy. Okay, what I would say is that even if these vectors were going down into the negative, I would deal with my x and y's as if they were positive first, and then I would use my own kind of common sense as which one would be the negative value and which one might be a positive value afterwards. Just while we're on this, if I wanted to find a unit vector of this particular vector, this direction, we know it's got length 20, so it'd be 1 over 20, 10i plus 10 root 3j, which you can see as 10 goes into 20, we could then call it 1/2 I plus root 3j, for example. Or I can even separate it out to 1/2 I plus root 3 over 2j. Okay, so you always have these other options when you're looking at unit vectors within it. Obviously, this particular question was just about the vector. Now I'll pop up a few questions for you to have a go at. Starting easy, getting a little bit harder, but I don't think there's anything too difficult that I can really ask you with this, but it's just about getting a bit of practice in. And as always, I'll pop the answers at the end of the video. Now, it's worth noting as we go into the next set here where we get slightly different ones, if you don't put a diagram where you clearly show your angle, like I have here, then you need to state whether your value that you've worked out for the angle is above that vector I or below it. Okay, which will become more important when you see D and E and F, stating whether it's above or below. However, it's clearly not 33.7 degrees. So I do need to be careful with this. So my actual value of theta is going to be 180 minus the 33.7, so 146.3 degrees. Now, what I actually prefer to do now is actually think about it and go, well, let's actually get rid of that tan theta and call it alpha when I'm working out my value, and then theta clearly links to the actual angle here. And doing the same with the previous part D, you know, just changing that into an alpha. And it's just a little bit nicer in terms of my terminology. I'm not using theta here and theta again with my theta and the angle in the diagram. So quite clearly this theta is in the diagram, my alpha is just an angle I'm working out. So you do have two ways in doing this, approaching it the standard way with the horizontal and then 90 minus it, or if you've got the diagram going straight in with it this way, so it's kind of your X over your Y, finding the angle in one go. Totally up to you. If I've got the diagram, I would tend to do it this way in green. If I don't, I tend to do it this way. However, I should say that you should always attempt to get your diagram. I'll always generally get a diagram and work it from there. So the remainder of these three, I'll do a diagram and then I might do them, you know, based on the diagram. Okay, everything I'll do will be based on the diagram. However, it's not 100% that simple. We do need to think about our cost. So we know that sine theta was 5/13. So sine is positive here, which is what give me these values. Sine is also positive in this section. Okay, so if you think of it in terms of this diagram, okay, that would be my theta with my 13, sorry, not 13, 26, 10 and 24, which is in that section. And then in the sine section, sine of this angle is also going to be positive. So that will still be 10, that's still going to have a distance of 26. Okay, the direction though this time would be negative 24. Okay, and that's quite important to think about. So in this, it does depend on what you're given here, whether you're given like sine or cos. Say I was given cos of theta, then I'd be looking in these two sections and my value of y would change. So my final answer is that, and I'll do this in red so it stands out, but P is plus or minus 24 and Q is 10, and that is the complete answer. Hopefully that's made sense to you guys.